In this lesson, tinoda kuita this particular question yedu, we want to do 11a and 11b. So tikatarisa pa 11a, zviri kunzi express 2 over n plus 1 n plus 2 in the form a over n plus 1 plus b over n plus 2, where a and b are constants. So that is what we want to start with. Saka, if you had noticed already, 11a is on partial fractions. Saka tikati 2 over n plus 1 n plus 2. Apo watotiudza kuti it should be in the form a over n plus 1 plus b over n plus 2. So how do we partialize this? Chekutanga, there's a principle we should appreciate. Let us say tanzi 1 over 2 plus dokvazvanzi 2 over 3. There are two ways of adding these two fractions. The first way, tinotsvaga a common denominator, which is usually the product of our denominators. Saka common denominator yedu inenge iri 2 times 3, which is 6. 2 into 6 ndi 3. 3 times 1 ndi 3 plus 3 into 6 ndi 2. 2 times 2 ndi 4. This gives us 7 over 6 as our answer. Another way of going about it, which is going to be the principle we apply here, tinotora half plus 2/3. This is equal to, we are going to multiply 3 times 1 plus to that 2 times 2, to that everything is over 2 times 3. Saka if you followed zvataita panapa, tatanga tati 3 times 1 ndokuzoti 2 times 2 ndokuzopesera na 2 times 3. Handiti ndakukuratidzai kuti we come to the same answer. 3 times 1 ndi 3 plus 2 times 2 ndi 4 over 2 times 3 ndi 6. Saka we are coming to 7 over 6 as before. So this is the principle we want to apply upper. Of course, you can do it this way. Mnongobuditsa the same answer because we want to add these two fractions, but I would that you do it the way I have shown you. So applying the way I have shown you, this is going to be 2 over n plus 1 n plus 2 is equal to, this bracket of n plus 2 is going to multiply a. So a times the bracket of n plus 2 plus b times the bracket of n plus 1. This is over, then the denominators multiply each other, n plus 1, n plus 2, like this. Saka kana taona kuti ma denominators afanana, for example, a over b is equal to c over b, ma denominators akafanana, we can do two things. Firstly, tinogona ku multiply both sides na b, like this. Ma b ochekana tosara tina a is equals to c. We can also just kana tajaira tinogona kutongo cheka ma denominators like that, kosara ma numerators are equal to each other. That is one thing we can do. So that is what we want to do here. Taona kuti ma denominators afanana, saka we are just going to cancel them out like this. Of course, you can multiply both sides by the denominator, you come to the same realization. Saka zvatava nazvo panapa, tavana 2 is equal to a n plus 2 plus b n plus 1. That is we have. Saka zvatakuda kuita, takuda kuchi eliminate either a or b kuitira kuti tiwane the other variable. Saka rega nditonyora pasi eliminating a, katitangena a. Saka if we want to eliminate a, we just have to make this bracket equal to 0. Saka since bracket iri riri n plus 2, zvoreva kuti to eliminate a, not let n be equal to minus 2. Kana mchida kuzviita in another way, you can just take bracket racho n plus 2, you equate it to 0, then n inge equal to minus 2. kureva kuti mukareplace n na minus 2, this bracket becomes 0. Saka we let n be equal to minus 2. Then we have to rewrite this. 2 is equal to a, n minus 2, so it's minus 2 plus 2 apo, plus b, n minus 2, so it's minus 2 plus 1. Saka, since this is 0, so a times 0 is going to be 0. Saka 2 is just equal to b. Then what is minus 2 plus 1? It's minus 1. Kureva kuti tikachidivide both sides na minus 1, tunaona kuti b are equal to minus 2. Okay. Saka this is how we eliminate a. Panapa we can then just take b for minus 2, we implant it here, but we cannot do that now. Why? Because we still have n. Saka what we have to do is we also have to eliminate b. So eliminating b. To eliminate b, we want this to be equal to 0. Since mina n plus 1, so we have to let n be equal to minus 1. Saka we just take this number and we negate it. N is minus 1. Saka panapa it means tichati 2 is equal to a. Then this is minus 1 plus 2 plus b minus 1 plus 1. Saka 2 is equal to a. Minus 2 plus 1 zvakafanana nekuti 2 minus 1 kureva kuti it's just 1. Then we know kuti b is multiplying 0 here, so it's been eliminated. Saka if 2 is equal to a, zvatova pachena. Saka tawana a, tikawana b. What then are we going to do? Tenge takungoya pano takunyora a therefore statement. Let me write it in a different color. Saka therefore 2 over n plus 1, n plus 2 iri equal to, tikadzokera ku original form inoi, a over n plus 1 plus b over n plus 2 ndo yatingechida kushandisa. Saka it's a 2 over n plus 1, then yanga iri plus, what is b? b ndi minus 2, minus 2 over n plus 2. Saka of course we can further simplify this. This will be equal to 2 over n plus 1 plus na minus ukasangana tunaita minus, so it's minus 2 over n plus 2. Saka this is the 4 marks dzanga dzichidikwa pa part A. Our aim is to do part B, but we cannot do part B without part A. So I hope you understood how we partialize those fractions. If there are any questions, please don't hesitate to ask in the comments or directly on our numbers on WhatsApp. So I'm going to remove this and only retain the answer kuti tikwanise kuita part B. You see, it's easy, and it. Okay, let us drag this. This is our answer to part A. We want to use it. Okay, keep it here like this. Saka takuda kuchita part B. Part B iri kuti hence evaluate. What do we want to evaluate? The sum of, cannot summation of, from n is equals to 1 up to the value k of 2 over n plus 1, n plus 2. Saka the word hence means following through. Correct, the answer we get per A is most likely going to be usable per B panapa. And you can see that A yanga shida kuti partialize 2 over n plus 1, n plus 2. Saka zora we can rewrite this as sigma from n is equals to 1 to k of 2 over n plus 1 subtracting 2 over n plus 2, like this. Mapaona. Saka this is tested under series and sequence. Correct, we want to establish terms edu what are they going to be. So zvatinoita manje tinoda iso, and I want you to listen carefully. We are going to replace n uyu, and saka manyorero ataita apa, let me use another color to illustrate zvandikureva. Izvi zvinongoreva kuti tichatangira pana 1 2 3 and so forth until pana k, and the number of terms is going to be incrementing by 1 from 1 up to the value of k. Saka knowing that, zvatinoita, we take the sum yakadai so now, tobva tati it's equal to, what is it going to be equal to? It's going to be equal to 2 over n anotanga in the value 1. Saka panapa tichati 1 plus 1, which is 2, subtracting, then apa tichati 2 over n d1, saka 1 plus 2, it's 3. Saka it's like this. This is going to be our first term. Katungoinyora iri in fractional form like that. Tobva tati, this is going to add our term number 2, n angava 2 now. Saka this is 2 over 2 plus 1, 2 plus 1 the 3, minus 2 over 2 plus 2 the 4. And our second term. Let us do our third term. Third term yedu manje inenge yakuti 2 over n ava 3, 3 plus 1, that's 4, subtracting 2 over 3 plus 2 the 5. Then let us maybe do our fourth term. Term number 4, n angari 4, saka it's 2 over 4 plus 1, 5, subtracting 2 over 4 plus 2, 4, 5, 6, and so forth, until what happens? Until tavana n is equal to k. And saka kana n are equal to k, that's 2 over k plus 1, subtracting 2 over k plus 2. This is going to be our last term. And so this is very critical. Mfunga kuona kuti chichaitika apa. Now maona kuti izo ndo zvaitika, ndoda kuti muchicherechedza. Let me be slower now. Kuti minus 2 over 3 unoyu anokanzelana na plus 2 over 3 ari pano. Mungozona? Minus 2 over 3 plus 2 over 3 ndi 0 ndokukanzelana kwacho. Minus 2 over 4 uno uyu anokanzelana na 2 over 4 ari pano. Minus 2 over 5 uyu anokanzelana na plus 2 over 5 ari pano. Samurikona iri pattern irikuitika kuti everything else is cancelling the other. Kuri kuti tada kuwedzera another term kumberi uku, just to show you. Another term inenge yava 1 2 3 4 fifth term kuroti n anenge ari 5. Saka 2 over 5 plus 1 is 6, subtracting 2 over 5, 6, 7, like this. Can you also appreciate kuti minus 2 over 6 arukanzelana na 2 over 6? Kuroti minus 2 over 7 achakanzelana na plus 2 over 7 arikuya kumberi. Saka tichita izvi tinoona kuti all the terms are going to cancel each other except the first and the last term. Tinogona kutozvidemonstrata futi kuti even 2 over k plus 1 is going to be cancelled. How do we do that? Tinofanirwa kutsvaga term inenge iri panapa. What is this term? Saka kuti tiwane that term, it's actually easy because we are going to reinterpret the sigma in this way. Tanga tambotaura kuti tiri kutangira pana n is equals to 1 until k. Saka tanga tati it's 1 2 3 and so forth until k. Saka toda kuziva kuti what is the term, kana kuti what is the term which comes before k. So it becomes 1 2 3 and so forth. Then before k tina k minus 1, then k. Murupabata. Saka kuti tiwane this term, it simply means we are going to replace n none na k minus 1. So let us do that. Saka this term iri just before the last term inenge iri 2 over k plus 1, sorry, 2 over k minus 1, toti plus 1. Then we are going to be subtracting 2 over its k minus 1 totatichi plus 2, like that. So if we evaluate this, tunaona kuti ingeri 2 over k minus 1 plus 1 subtracting 2 over k minus 1 plus 2, which gives us 2 over minus 1 plus 1 is 0, so it's 2 over k subtracting 2 over, then minus 1 plus 2 the plus 1, saka pa it's k plus 1. Saka this is the second last term. Then if you look closely, pana patina 2 over k plus 1, kurewa kuti acha cancelana na minus 2 over k plus 1, like this. Saka we have proven kuti even this term is going to be cancelled, but the last term is remaining not cancelled. Saka what we've established here shows us clearly kuti pane pattern iripo kuti this term is going to cancel the next term to such an effect kuti even 2 over k plus 1 is going to be cancelled, tongosara ne the last term. Saka zvinhu zvese zviri pakati it's going to be cancelled. How did we establish that? Taona a pattern iri pano kuti from the first bracket only the second term is cancelled. Saka we also infer kuti from the last bracket only the last term is not cancelled. Murukupaona. Saka zvadai so zvinongoreva izvo kuti tinenge takuita rewrite this like this. Takungoti k n is equals to 1, 2 over n plus 1 subtracting 2 over n plus 2 is equal to the first term 2 over 2 subtracting the last term 2 over k plus 2. Those were yaita. Saka kana tadai so we can now just simplify this fraction. How do we do that? 2 over 2 ndi 1, saka it's 1 minus 2 over k plus 2. Kureva iko kuti if we subtract these two, it's going to be k plus 2 multiplying 1, tichichansa method yatambo discussa kwekutanga, then toti minus 1 multiplying 2 over 1 multiplying k plus 2. Saka our answer here is simply k plus 2 subtracting 2 over k plus 2. Correct, this is equal to k, since 2 minus 2 is 0, over k plus 2, like that. Saka this is our final answer. Tikadzokera question kwedu kunoku iri kuti hence evaluate that in terms of k, sateta kungouya pana patakuita rewrite this toti this is equal to, what is it equal to? K over k plus 2, k over k plus 2, tatowana 6 marks. Saka chakakosha panapa ndechekuti you interpret that summation, that sigma notation, and you find a pattern. Mawana pattern, you infer that pattern to k, then you just do the symbol evaluation. I don't know if I have explained it sufficiently enough. If not, please comment in the comments. If yes, may you please consider subscribing, liking and sharing. And if you want to join our class doing pure maths A level, WhatsApp us on +263 71 521 3310. Thank you and take care.